Okay, good evening, dear students. Just check. Do you hear me? Is it visible screen?
Yes, it is.
Okay, so we can start, I think. So today we will consider just some kind of exercise from previous different kind of exams, and we will start. So let's consider first question. And according our this question, we have just 1, 2, 3 points, and we have to consider just area of triangle where vertices will be given points. So how can we solve this kind of problem? I think it's not so difficult. Such kind of problem we already consider it on our practice, but main idea now is that if we have point, we can construct just some kind of we can construct some kind of triangle, and vertices will be A, B, and C. So we can construct just vector AB and AC, for example. We can construct this kind of triangle ABC, and we have to just compute array of triangle. We can consider just this vector we can denote by A vector, and this vector may be some kind of B vector. And in our this situation, we can consider this kind of formula where A cross B is just cross product of A and B vectors. We know that from property of cross product that please mute your microphone. Okay, so from our this formula, we see that we can consider cross product of A and B, and this cross product will be just our parallelogram, which will constructed using our these ABC points. So area of our this parallelogram will be just cross product, and our requested area of triangle will be half of our this area of parallelogram. Now we can construct, we can check. Maybe now I will just consider some kind of so now how can we construct just cross product of A and B? A cross B, these are vectors, is just we can consider determinant where first row will be A, J, and K vectors. A, J, K vectors are just our given unit coordinate vectors in three-dimensional space. Now you see we have just three-dimensional space because each of our these points consists of three coordinates, P0, P1, and P2. So we can consider, for example, A. We can consider vector A, and vector A we will denote like now. It will be just A. It will be our this P0. B, it will be P1 point, and C point will be P2 point. So now A vector is just vector P0, P1. P1. And coordinate of our this vector we can compute. So coordinate will be just, we have to just consider from coordinate of P1, we can subtract coordinate of P0. So in our this case, we will obtain 0 minus 2, it will be minus 2. Then again, we can consider 0 minus 0, it will be 0. And 0 minus 2, it will be again minus 2. So it is vector P0, P1. We can consider again B vector. And B vector will be just vector P0, P2. Maybe it's more convenient considering our these given points take please mute your microphone. And maybe more convenient if you will take instead of A0 point just P1, because this is origin point, but it doesn't matter which point you can take in our these vectors. Let's continue our these choose. So P0, P2, it will be just vector 1 minus 2, it will be minus 1. Then we can consider 1 minus 0, it will be 1. And 1 minus 2, it will be minus 1 again. So these kind of A and B components we have to put in second row. Okay. So now we can consider second row, it will be just coordinate of vector. Oops. Some kind of problem. We have here. So second coordinates we can put here, minus 2, 0, and minus 2. Then third row, it will be minus 1, coordinate of B vector 1 and minus 1. So we can compute this determinant, and this determinant will be equal just I multiplied by, we can consider cofactor of I, which will be this one. And determinant of our this cofactor will be 0 by minus 1. It will be 0, and minus 2 or minus 2, it will be 2. Then we can consider plus minus j, because in our, when we will compute our this determinant, we have to consider expansion according to first row, and elements of first row will be just include to our this determinant with different alternative sign, I with positive, j with minus, and k with plus again. So j, what will be cofactor of j? We have to just ignore second column and first row, and we will obtain minus 2, minus 2, minus 1, and minus 1, which will be just 0, because you see these two, minus 2 and minus 2, minus 1 and minus 1, two rows are proportional. That's why determinant will be equal to 0. Then we have to consider just plus k, and cofactor of k, we have this one, and it will be minus 2. So determinant, we have vector. This vector, we can write components of our this vector, I, j, and k components we have to take here. 2 according to I, 0 according to j, and minus 2 according to our this k. So we have to consider norm of our this vector. Norm of our this vector will be equal just square root, we have to consider 2 square plus 2 square. It will be 4 plus 4. So it will be just, now we can consider 2 square root of 2. Okay, so this is area of parallelogram, and area of triangle will be half. So answer is just this kind of square root of 2. Okay, have you questions about this kind of exercise?
All right, for the last thing, can you repeat the algorithm of finding it step by step?
Cross product, you mean?
No, everything.
Everything.
Algorithm.
Okay. So we have points P0, P1, and P2. If we have this kind of 3 points, from these 3 points, we can consider, for example, P0, P1, and P2. So from these points, we can construct 2 vectors, like here, A vector and B vector. How can we construct vector A? Vector A is just, sorry. Vector A is just a vector which connect P0 and P1. Coordinates of vector A will be just vector which components computed by next way. We have to just consider first component of P1, subtract first component of P0. So from 0, P1, we have to subtract just 2, and it will be minus 2. We will obtain first component of this A vector. Second component, we have to again, from second component of P1, which is 0 above, you can see. We can subtract second component of P0. It will be 0. 0 minus 0, and second component, we will obtain just 0 here. Then we can consider third component of P1. Third component will be just P1. It will be 0. And third component of P0 will be 2. So 0 minus 2 will be minus 2. So we have just components of our vector A. By similar way, we can compute components of vector B. Vector B is just vector P0, P2. So from P2 coordinates, we have to subtract corresponding coordinates of our P0. So 1 minus 2 will be minus 1. 1 minus 0, it will be 1. And 1 minus 2, again, will be minus 1. So we have 2 vectors, A and B. A and B vectors. Using A and B vectors, we can construct parallelogram. Here you see this parallelogram we have. And according to rule, according to property of cross product, this kind of cross product we can see. So area of this parallelogram constructed based on our A and B vectors. So area of this parallelogram from properties of our cross product equal just norm of vector A cross B. A cross B, really, it will be some kind of vector, but norm of these vectors, norm of vectors will be just equal. Norm will be always scalar value, real value, and now this norm will be equal just area of our parallelogram. And requested area of triangle, this triangle, P0, P1, P2. This area of triangle is just half of this area of parallelogram. That's why we have to just compute cross product, norm of this product, and divide by 2. How can we compute cross product A, B? This is standard way. We have to consider determinant. If we have to construct determinant, where first row is ijk. Ijk are just coordinate vectors of our space, 3-dimensional space. These are basis vectors, standard basis vectors for R3. This is just I, J, and K vectors. Then in second row, we have to put coordinates of A vector, which is just -2, 0, -2. And in third row, we have to put coordinates of B vector. Then compute determinant. Determinant of our this matrix or our this determinant, we will compute using expansion according to first row. Expansion of first row. It means that we have to just I, here I, multiply by cofactor of I. Cofactor of I will be constructed from original determinant by ignoring our first row and first column. If you will ignore first row and first column, you will obtain just determinant consisting of elements 0, -2, 1, and -2. And this determinant will be equal. We will use product of diagonals, 0 by -1, -1 multiplied by -2. So result will be -2, or it will be 2. So it I multiplied by 2. 2 is value of our this cofactor, determinant of our submatrix. By similar way, we can consider -j. Why minus? Because according to our rule of expansion, elements of first row should be taken with alternative sign. I will be taken with plus. That's why we can just put plus I multiplied by 2. Then j we have to take with minus, alternative sign, -j multiplied by cofactor of j. Cofactor of j, we have to ignore first row and second column. If we will ignore first row and second column, cofactor will consist of elements -2, -2, and -1, -1. -1, -2, -2, -2, and -1, -1. So this is determinant. -2, -2, and -1, -1. But this matrix, determinant of our this matrix equals 0. Why? Because two rows are proportional. That's why determinant will be always 0. If two rows or two columns of determinant are proportional, matrix are proportional, then determinant of this matrix will be equal to 0. That's why -j multiplied by cofactor. Cofactor is our this determinant, but determinant equals 0. -j multiplied by 0. By similar way, we can consider k with plus multiplied by cofactor. Cofactor of k, we have to just ignore first row and last column, third column. We will obtain determinant consisting of -2, 0, and -1, 1 matrix. And determinant of our this submatrix, we will compute by considering product of diagonal, -2 by 1, -1 by 0. So it will be just -2. So this is just our determinant. And you see now our these coefficients of our I, j, and k are just components of our this vector. This is determinant will be vector. And this vector is just vector of our this cross product. And coefficients of our I, j, k, it will be just vector -2, 0, and -2. So this is just vector, which is just our cross product. So now next step, we have to consider norm of our this cross product or norm of our this vector. How can we compute norm of our this vector? Norm of vector is just square root of square of components. 2 square 4 plus 0 square 0 plus -2 square also 4. It will be square root of 8 or it will be just 2 square root of 2. So this is just array of parallelogram. We are requesting from here just array of triangle. That's why this array of parallelogram we have to divide by 2, and we will obtain answer square root of 2. Is it clear now?
Yeah, thank you. It's clear
Mhm.
now.
Okay.
Yes.
You're asking me just can we compute, calculate distances between points instead? Yes, you can consider here, for example, you can compute P0, P1, this distance, then P1, P2 distance, and P0, P2 distances, and then use Geron formula to compute area of our this triangle. Yes, but I think number of calculations in our that case will be more than number of computations in our choice, I think. Because distance, to compute distance, you have to just again construct vector A by similar way. Then you can consider norm of our this vector A, norm of vector A, it will be distance between P0, P1. Similar. Then you have to consider distance between P0, P2. It will be again vector this minus 1, 1, and minus 1. You can compute this norm of our this vector. And additionally, you have to compute norm of vector P1, P2. Then using Geron formula, you have to consider just again square root of our these products. So I think you will have more number of computations, I think. But you can compute this way, by this way also. Okay. Let's consider next. So now let's consider this situation. We have to consider line R. What is line R, first of all? You see, this is first, we have to consider which kind of space we are considering. A line may be in R2 or it may be R3. In our situation, we have R3. Why R3? Because in our these equations, we have just variable z as well. So we have 3 variables, x, y, z. That's why all our this line is in R3. We are considering just now just R3 space. Oops. R3. And in R3, we have just really now we have 2 equations. First equation is just x minus y equals 0. And second equation is just x plus y minus z equals 0. So we have system of equations. What will be meaning of each our these equations in our this system, this and this one? These are just linear equations in 3-dimensional space. Linear equation, any linear linear equation in 3-dimensional space will be just plane. So plane x minus y equals 0, it will be one plane. X plus y minus z equals 0 will represent second plane. So we have 2 planes in our R3 space. system means that we have to consider intersection of solutions. Intersection of two planes is just line. In three-dimensional space, if you will take any two planes, now these planes not parallel, they are not parallel. Why they are not parallel? Because planes will be parallel if their coefficients will be proportional. But now you see coefficient x minus y and 0, coefficients will be 1, minus 1, 0, and 1, 1, and minus 1 are just not proportional. That's why these two planes are not parallel. Any two non-parallel planes intersected according to line. That's why our this system represent line in R3. Line in R3. Okay. Now we have to just consider any line in R3, like here. We can represent in our this general form, this form of parametric equation of line in R3 we can see. This is general equation, parametric equation of line. And what about this line? What can we say about this line? Right side of our these equation systems are just 0 and 0. It means that these two lines go through origin point. So two lines through origin point. That's why parametric equation of our this line, two planes, x minus y equals 0 plane, and second plane also will go through origin point. That's why intersection of our these two planes also will go through origin point. That's why parametric equation of line solution space of our this intersection will be just x equal tv. When t is just some kind of parameter, t may be any real number. V is just vector, some kind of vector, which will be parallel or lies on our this line. So this is equation of line, which will be parallel to V and go through origin point. Why our this equation or this line will go through origin point? Because really we have to put here some kind of point x0, vector x0, but in our this situation, point x0 will be equal to 0 to show that our this line goes through origin point. Okay. So this x0 we can just eliminate. And let's consider how can we obtain this kind of x equal tv equation. To compute this equation, we have to solve this equation system. You see, we have two equations and three unknowns. What can we do? How can we solve this kind of system of equations? One of our these variables, now it's more convenient to choose z. We can z put some kind of parameter t, and then using our this z, we can consider other one. So x minus y equals 0, and x plus y equal minus z. Minus z we have to just put on right side. X plus y will be equal z or t. So we have this kind of equation. Then you have to solve this equation system. X plus y equal t and x minus y equals 0. Okay. So you can see x equal y. You can put in first equation, and from first equation you will obtain 2x equal t, or x equal t over 2, and y equal also t over 2. That's why parametric equation of our this line will be just x equal. We can consider this kind of solution: x equal t over 2, y equal t over 2, and z equal t. That's why our this solution will be equal. Just solution, we can write vector x, y, z will be equal. We can write some kind of vector, which component will be x component will be equal t over 2, y component will be just t over 2, and z component of our this vector will be equal t. T always we have to just put outside of our this brackets, and inside of bracket we will obtain just, we will put coordinates of our vector according to x. X equal t over 2, t outside, that's why inside we will put 1 over 2. Y coordinate equal t over 2, t outside, that's why inside we will obtain 1 over 2 again. And z component t outside, inside we will obtain only 1. So we have vector 1 over 2, 1 over 2, and 1. And this vector, we can consider t is any real number. Any real number, it means that we have to just multiply this vector by 2 to avoid our these rational components. If you will multiply by 2 all components, you will obtain vector v, which component will be 1, 1, and 2. So it will be just this one. So v vector from our parametric equation is just vector which will be parallel to our this given line, or it will be just line will have the same direction like vector 1, 1, and 2. Okay. Questions?
Clear.
Okay. 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 So now you see we have just in question 3, we have a system of equations, and we have to solve this system and then answer our these questions. Choose the correct answer. Okay, let's consider how can we solve this kind of system. Okay, maybe I will write here. So we have to construct a matrix. Matrix of our this system will be equal 1, minus 2, and 1. Augmented part will be equal 2. Second component of x, y, and component of z in second equation will be 0. Right side will be 4. Then we have 1 component of x, 0 component of y in third equation, minus 1 and 1. So this is just our augmented matrix. Augmented matrix. Sometimes in your in our this quiz, instead of augmented matrix, you can meet term complete matrix. Complete matrix and augmented matrix are just synonyms. Okay, then we have to just use Gauss elimination. Gauss elimination, so we have to just consider equivalent. What can we do? maybe we can first row we will not change 1 and 2. Then we can just multiply first row by 2 and add to second row by minus, yes, by 2 and add to second row. All elements of first row we have to multiply by 2 correspondingly and add to corresponding elements of second row. 2 by 1, 2, and minus 1, it will minus 2, it will be 0. 2 by minus 2, minus 4, and plus 1, minus 3. Okay. Then 2 by 1 and 0, it will be 2. Then 2 by 2, it will be 4, plus 4, it will be 8. Okay. Then our goal to reduce our this form, reduce our this matrix, we have to consider third element. How can we convert this element by 0? We have to multiply first row by minus 1 and add to third row. So we will obtain 0 here. Minus 1 by minus 2, it will be 2 by 0, and plus 0, it will be 2. Then minus 1 by minus 1, it will be minus 1 plus minus 1, it will be minus 2. And third one, minus 1 by 2, it will be minus 2 and plus 1, minus 1 we have. Okay. So what can we say about this kind of matrix? We don't need to continue this process. Why? Because in our this case, you see that our this matrix will have one leading element we have here. Second leading element will be in second row. And second row and third row are not proportional. Not proportional, it means that we cannot convert third row full on our to 0. That's why so in our this situation, we have to just see that 3 rows are linearly independent, because we will have first row, second row, and third row. Second and third row linearly independent because they are not proportional. And we can choose corresponding leading element in third row as well. That's why our this matrix will be invertible matrix, or determinant of our this matrix will be differ from 0. Determinant will be differ from 0. That's why we will have unique solution. So system will have a unique solution. So it will be a correct answer. You can compute such kind of or solve this system computing just determinant of our this main matrix. This determinant of this matrix you can compute. And you can see that determinant will be differ from 0 as well. But I strongly recommend you just not starting with determinant. This our Gauss elimination, it will be more general method. General method which allows us to distinct or to consider different kind of variants. From row echelon form of matrix, you can just make different kind of conclusion about number of solutions, including this kind of unique solution case as well. Okay.
All right. When the determinant isn't equal to 0, so it has a unique solution.
Yes.
What if
yes.
it's equal to 0?
If it will be equal to 0, determinant will be equal to 0. So it depends on what will be right side here. So now we can consider this in our situation, different situations we can meet. I will not now just computing this one. Suppose we will continue this process. If you will continue this process, so here you will obtain 0. Here you will obtain some kind of number. I don't know which kind of number will be here, but we can consider here and here. Here will be 0. Okay. If we will continue this process, you will obtain such kind of matrix. And this matrix here, determinant will be 0 if this last row also will be 0. If these three elements will be 0, so determinant will be equal to 0. So in that case, all depends on what will be on right side here. If right side will be 0, so last row will correspond to equation 0 on left side, and on right side also will be 0. And in that case, we can say that we will have just infinitely many solutions. Infinitely many solutions. If right side will be not 0, you will obtain contradiction. 0 equal non-zero. Non-zero. Some kind of number. So in that case, it will be just not 0. In that case, you will obtain contradiction, which means that number of solutions will be 0. So we have no solution. Again, in which case our system will have two solutions. Two solutions now cannot be. Why? Because any system of equations may have only 3 possibilities for number of solutions. Unique solution, 1 solution. No solution, or it may be infinitely many solutions. This, and this may be possible variants for number of solutions. Never we will have only 2 solutions. Never. So we can see here we have just a unique solution in this exercise. If determinant will be equal to 0, so you will obtain always infinitely many solutions, like here. If determinant will be equal to 0. Otherwise, if 0, you will obtain infinitely many solutions. Okay.
All right, thank you. Clear.
Mm-hmm. Okay. Now we have matrix A, and we have to find right statement. What will be A minus 1? I think the effective way is just use definition of A minus 1. Definition of A minus 1 means that product of A and this kind of matrix A minus 1 should be equal to I, identity matrix. Identity matrix is just matrix consisting of 1, 1, 1, and all elements other will be 0. Okay, this is matrix, 3-dimensional matrix, and 0 as well. We have here 0, 0, 0, and 0. So this is just identity matrix of order 3. We have to check for which of this given A minus 1, this kind of equality will be correct. How can we check? Let's consider just first row of A. We have to just multiply A by A minus 1, 1 by 1 vector, 1 by 1. So let's consider first row and first column here. First row and first column, 1, 0, 0 multiplied by 1, 0 minus 1. Scalar product, 1 by 1, 0 by 0, and 0 by minus 1. It will be 1. So 1 we have. First row, we have to multiply by second row. What will be result? Second row will be also product of first row by second row, second column will be again equal to 0 because 1 by 0, 0, 0. So it will be just 0. Now is correct. First row by second column, third column. Third column again will be equal to 0. So 1, 0, 0 we have. Then we can consider second row. Multiply second row by first column. What will be result? Minus 1 by 1. It will be minus 1. 1 by 0, 0. And 0 by minus 1 will be 0. So second row multiplied by first column will be equal just element 2, 1. Second row multiplied by first column should be equal here. Oh, sorry. Element 2, 1. Element 2, 1 equals 0. But now you see for first our A matrix, element 2, 1, second row by first column will be not 0. Should be 0. That's why it's not correct. Which we can check second B matrix. First row by first column will be 1. First row by second column will be 0. And by third column also will be 0. But what about second row? Second row by first column. It will be minus 1 and 1 and 0. Okay, 0. Second row by second column should be 1. But now result minus 1, 0, minus 1, 1, and 0, 1. Result will be minus 1. So it's not, again, not correct. Third one, you can compute. Again, first row by first column, it will be just 1 minus 1. It will be just 0. First row by second column, again, we will obtain 0. First row by third column, again, will be 0. Okay. Second row, minus 1, 1, 0. Multiplying by first column, it will be 0. Okay. Second row, it will be just minus 1 again. So it's not correct. Second row of A multiplied by second column of A minus 1 will be equal minus 1, which is not correct. So correct answer will be just D, I think. Okay. Okay, this is just multiplication. Okay, have you questions about this exercise? No?
It's clear.
Okay, next one. Let's consider question 5. So we have to consider linear map F from R3 to R2. And we have to just compute, consider just next. We have to be careful in our this situation. We have to find which of our these following statements will be not correct. Oh, sorry. Not correct. Cannot hold. Okay, let's consider. If we have just map from R3 to R2, so we can consider what will be matrix of our this map. If we have just two Euclidean vector spaces, R3 and R2, any map from one Euclidean space to another Euclidean space always will have corresponding matrix. And all properties of F will be the same like properties of corresponding matrix. What will be matrix of our this map in our this situation? If we have map from R3 to R2, that's why then in our this matrix will be size 2 by 3. 2 by 3 means that 2 rows and 3 columns. Okay, so let's consider which of our these situations. In our this situation, this map cannot be injective. Why? Let's consider a property of injectivity. In our this situation, we have 2 by 3 matrix, and it means that number of columns will be here 3. Three columns. And in our this situation, matrix will be just injective if and only if kernel of our this matrix will be just 0 space, 0. But it cannot be correct. Why? Because in our this situation, dimension of kernel will be nullity, and we have formula nullity plus rank should be equal number of columns. Now it will be just 3. And what about this nullity? Nullity will be equal 3 minus r. But nullity will be 0 only if r equals 3. But r now cannot be equal to 3. Why? Because matrix is 2 by 3. Rank, r is rank. Rank of matrix cannot be more than each of our these dimensions. It cannot be more than 2. That's why rank may be 2 or less than 2. In any case, our this nullity will be not equal to 0. Nullity will be greater than 0, greater than or equal to 1 at least. That's why our this map or transformation F will be not injective. That's why correct answer will be this one. Let's check other in our these situations. So first statement will be wrong, false. Other statements should be true. Dimension of kernel F greater than or equal to 1. Yes, because nullity is dimension of kernel, and just this is correct. Matrix associated to F has rank 1. It may be rank 1, maybe. So this kind of statement may be not wrong. Maybe yes, maybe no, but it's not strictly not wrong. Dimension of image F, again, the same. Maybe 2 or maybe not 2, because dimension of image F is just column space. Column space. but dimension of column space. But dimension of column space is just equal to rank always. Column space, dimension of column space, dimension of row space, always equal to rank. Rank will be equal to or 1 in our this situation. So maybe yes, maybe no here, D. And only in statement A, we can just exactly say that it will be wrong. B is true. C and D may be true, may be wrong. We cannot exactly say that C or D will be wrong. That's why the correct answer will be A. Okay. Okay, Azbek.
C and D depends on how much leading elements we'll have in matrix
Yeah.
A, right?
Yes.
Oh, okay.
Yes. It may be 2, it may be 1. In any case, rank may be 1 or 2. So it's not exactly wrong. Maybe wrong, maybe true. So, but now we have to just find statements which will be not true. Not true, it means that it will be wrong, exactly wrong. Exactly wrong or false will be only our this statement A. Okay.
Okay.
Let's consider 6. Vector V, vector V1, V2, and V3. First of all, it will be vectors in R4. Why in R4? Because each of these vectors consists of 4 components, you see. That's why we are really deal with R4. Let's consider, and we have to just find the right statement now. Correct statement. A. V1, V2, V3 is basis. No, it's wrong. Why? Because in this situation, 3 vectors cannot be basis for R4. Basis for R4 consists of exactly 4 vectors. This is not enough. That's why A will be wrong. Let's consider from here, what can we consider next? Again, we have to consider here subspace generated by V1, V2, V3. Subspace generated by V1, V2, V3 is just row space. If we, from this V1, V2, V3, we will construct some kind of matrix, so it will be matrix 1, 0, 3, 1, 1, 0, 1, 1, and 1, 3, 2, 1. We can consider this matrix, and we can check how many linearly independent rows we will have here. Each row corresponds to vectors V1, V2, and V3. If number of linearly independent, or now we have to just again consider row echelon form of this matrix, and again we have to check how many leading elements we will have here, and number of leading elements of this matrix will show us just which of these rows will be linearly independent. So we have to just compute here, because B, C, and D all depend on this matrix. So we have to consider row echelon form of this matrix. First row 1, 0, 3, 1, not change. Then from second row we can subtract first one. It will be 0, 0, 1 minus 3 minus 2, 0. Third row, from third row we have to subtract again first to reduce 0, 3, minus 1, and 0. Okay. Then we can just maybe first row we will not change. In second, these two rows we can interchange. That's why we will obtain 0, 3, minus 1, 0, and 0, 0, minus 2, and 0. So how many leading elements we have here? 1, 3, and minus 2. 1, 2, 3. 3 leading elements you have in a row echelon form. It means that all 3 rows or all 3 corresponding vectors v1, v3, v3, v2, v3 are just linearly independent. That's why correct answer will be just C. Okay.
What about dimension of the subspace?
Yes, dimensional of our this subspace will be also equal to 3.
It depends on how many leading elements we have, right?
Yes, how many leading elements in row echelon form we have here? So 3. That's why dimension will be equal to 3.
Okay.
Okay. Let's consider 7. 7. So we have this kind of quadratic form, and we have to just answer if our this quadratic form will be negative definite, positive definite, indefinite, and what will be matrix associated to this kind of quadratic form. Okay. Maybe we can start with a more simple way. We can reconstruct our this quadratic form like x minus 2y full square. We can take from first and second components, and it will be minus 4y square. We can put here to keep balance, and minus y square again. Okay, these 3 components is the same like this one, and minus y square. This is square. Okay, so result will be just our this square minus 5y square. What can we say about this quadratic form? Minus. What meaning Q is negative definite? Negative definite means that for any for any xy, our this expression will be negative. So now you see it's not.
Could one also say that a negative definite would have all eigenvalues less than 0?
Yes, yes. No, negative definite means that our this quadratic form will be negative for all our these non-zero elements, non-zero xy's. So in that case, it will be negative definite. Positive definite means that it will be always positive for all non-zero xy's. And indefinite, if our this quadratic form may get, for example, positive value and negative value, like here. For example, you see, we have we can construct here. How can we obtain from here some kind of 2y square minus 5y square? For example, if you will put instead of y 0, and instead of x you can put any number non-zero, you will obtain positive. Yes, positive, because y will be 0. You can take any a0 point. If you will put here instead of x a and instead of y 0, you will obtain positive value if a will be non-zero. Okay, so in that case it will be just positive. how can we obtain negative? This value will be negative if you will take, for example, x will be equal to 2y. So you can compute instead of y a, and instead of x you can put 2a. If you will put here, so x minus 2y will be equal to 0. And y will be equal, in our this situation, this one will be 0, but this one will be just minus. So it will be negative. That's why for this value we have positive, and for this value we have negative. So it means that our this quadratic form will be indefinite. May obtain, may accept just positive and negative values. That's why our this quadratic form will be just indefinite. Really, in your exam, you don't need, if you already find a correct answer, like here, so you don't need consider other statements. Because in our this quiz, always we will have only one correct answer. Okay, but now you can just for our this is just for exercise, we can consider what will be matrix of our this quadratic form. Yes, matrix will be not this one. Why? Because how can we construct this matrix? This matrix will be equal just 1 and 1 on diagonal, 1 and minus 1, sorry. It will be coefficient of x square and y square. And here we have to consider coefficient of xy divided by 2, minus 2 and minus 2. So this is just matrix of our this quadratic form, which is not this one. So D also not correct. Okay, the only correct answer is just indefinite. Q is indefinite. Okay. Have you questions about this one?
No question.
No. The matrix
really, you have alternative way here, but it's not so effective way. You can consider here, for example, you can compute eigenvalue, because eigenvalue for second order determinant, second order matrix will consist of 2 eigenvalues. So you will obtain quadratic equation, and then you have to just solve this quadratic equation and compute if our this eigenvalues will be different sign, or it will be just positive, both will be positive, or both will be just negative. So in that case, you can see what will be situation. Because a situation with eigenvalues is just strictly correspond to situation with our quadratic form. Okay, but I think this way is more effective way, and less number of computations. Okay, 8. Okay, 8 again. We have some kind of conic C in a 2-dimensional space. Conic means that we have just some kind of hyperbola, parabola, or degenerate, or just some kind of situations. So we have to just consider which kind of situation we can meet here. This is not, we cannot apply previous way, because in our this situation it was, we had no any linear path here in previous 7 exercise. That's why we can just consider full square. But now we have just again some kind of cross product xy, and we have x and y. That's why previous method not work here. That's why we have to just follow our general method. General method means that we have to first of all construct a matrix. A matrix is just matrix corresponding to quadratic form. So we have to construct this matrix. Coefficient of x will be 1. Coefficient of y square will be 2. Then we have put here. Then coefficient of xy will be 4, and this 4 will divide by 2 and 2 put here. So this is A. Then we have to compute determinant of A. This is matrix of quadratic form. Matrix of quadratic form will be 2 minus 4. It will be less than 0. Less than 0. That's why, in general, we have situation. It may be a hyperbola, but it may be degenerate case as well. To exclude this degenerate case, what can we do? We have to just consider our B matrix. B matrix, which will correspond to all our this left side. So we have to A matrix put here, 1, 2, 2, and 2. And then consider here linear path. Coefficient of x, half of this coefficient we will put here, and half we will put here, x. Coefficient of y, linear y, we have no, that's why 0 and 0. And then we can consider constant term, 3 we can put here. And then we have to compute determinant of this B. What about this determinant? If this B, we can see on lecture, we have considered this kind of criteria. On this picture, you can see this criteria. If determinant V will be differ from 0, like here, so in that case, we can consider different kind of situation. If A will be less than 0 determinant, that's why hyperbola. If determinant A will be 0, parabola. And if determinant greater than 0, it may be ellipse or imaginary ellipse. Okay, but now we are interested in if this B will be degenerate or not degenerate. This form, quadratic equation, sorry. We can compute determinant of B. Determinant of B, how can we compute this determinant of B? We can compute by different kind of way, and now you can just compute and see that this B determinant will be different from 0. Okay, for example, you can take expansion according to last column, because we have here 1 and 3. So we have to take 1 determinant. It will be 1. Here. You can take 1, multiply by determinant. Determinant, it will be this one. And this determinant will be equal to by 0 minus 2. So it will be minus 2. Then plus 3 multiplied by determinant. Determinant of cofactor will be 1, 2 minus 2 by 2. 2 minus 4, it will be minus 2. So you see, in any case, this is not 0. So determinant of B not 0, it means that this equation will be not degenerate conic, not degenerate. That's why determinant A depends only on determinant of A, less than 0. That's why it will be hyperbola. Hyperbola is correct answer. Okay. Have you questions about this one?
So when the determinant is 0,
if determinant V will be 0, So in our this case, we will have degenerate conic.
Zero. Permanent.
Degenerate conic. Degenerate means that it will be not hyperbola, not parabola, not ellipse. It will be just which kind of situation it may be, because we can obtain one point, for example, origin point. It may be a line, equation will convert to line, or equation will represent two lines. So these three situation may be, and this situation will correspond to degenerate conic. Degenerate conic. Okay. Yes, Azbek.
Is this the situation only for conic in R2 or for any space?
No. Only in R2.
Okay.
Because we have just A, B in our this situation. B is should be 3 by 3. So it means that we have to only X, Y. Maybe we can just construct some kind of construction for R3 also, but it will be very difficult, very complicated, and we have to just include there some kind of C matrix, but it will be, I think it's very difficult to consider just in quiz situation in your exam. Okay, that's why we will consider only R2 conics. Okay, next one. Okay, so what can we do now? Okay, we have just some kind of endomorphism. If our this transformation or map will be from R3 to R3, from Rn to Rn, such kind of map called endomorphism. I say an endomorphism because during your exam you can meet such kind of term. Endomorphism, it's just analog of operator. Operator, endomorphism are just transformation from V to V. Okay, so now we have to consider just you see all our these statements about eigenvalues, and eigenspaces and so on. That's why in any case we have to consider eigenvalue or eigenspaces. It means that we have to construct first of all matrix of our this transformation. We have to write explicitly. And what will be matrix in our this situation? Let's see. So how can we construct matrix of our this transformation? So we have to, in our this case, we have to take first component. On right side we have vector again. This transformation from R3 to R3, it means that if on left side x, y, z will be some kind of vector, on right side again result of our transformation will be again vector. And now you see it will be vector consisting of three components: first component, second component, and third component. So it's really three-dimensional vector. Each component coefficients we have to put in our matrix. 1, 2, and 3 from first component. Second component again 1, 2, and 3. And third component again will be 1, 2, and 3. Okay. Then we have to consider just now construct A minus lambda A. What will be a minus lambda a in our this situation. First of all, what can we say from just without computation? What can we say about this matrix? From our this matrix, we can see that 0 is our eigenvalue, because a minus lambda I, if instead of lambda you will put 0, so determinant of a minus lambda I will be equal to 0. That's why 0 is eigenvalue here. That's why we can consider, for example, we can exclude our b. B cannot be correct. Why? Because one of our these eigenvalues always will be exactly 0. But now you see lambda 1, lambda 2, lambda 3 differ from 0. C, again, 6, 1, and 2 also will be not correct. D, 1, 2, and nothing about 3. And F also not correct. Okay, continue. So we have to consider A minus lambda A. A minus lambda A, and we can consider this kind of one of our this lambda will be 0. And what about others? We can consider maybe just this one. We can check this, and this one. Okay.
In
Let's
D,
check.
there's no eigenvalue 0, so we don't have to consider it.
1 or, for example, 6. Which kind of, we can compute. So let's consider A minus lambda I. Yeah, A minus lambda I will be, instead of lambda, we can put, let's check 1. If we will put 1, so it will be 1 minus 1, it will be 0. Then 2 and 3 we have. Second row 1, 2 minus 1, it will be 1, 3, 1, 2, and A minus lambda I, it means that from 3 we have to subtract lambda or 1. So A minus lambda I, this is matrix A minus 1 I. We are supposing that 1 will be eigenvalue. But what in our this situation? What about this determinant? This determinant should be equal to 0 to be 1 eigenvalue. We can compute this determinant, and determinant will be equal. So can compute exactly this kind of determinant. So we can expand according to this first column. So 1 multiplied by minus 1 multiplied by cofactor. So we have to ignore second row and first column. It will be 2 by 2 minus 2 by 3. It will be 4 minus 6. It will be minus 2. Okay. And plus 1 multiplied by cofactor. Cofactor will be 2 by 3, 6 minus 3. It will be 3. So what will be result? 2 plus 3 will be equal to 5. What it will be differ from 0. It means that 1 is not eigenvalue. That's why this kind of D will be not correct. What else? So A also will be not correct because we have 1 here. And the only correct answer is just this one, E. Okay. You don't need consider, just check if really E will be correct answer. We can check if you want. I think on exam you will have no time to check this kind of situation. But if you need, you can consider what will be just now. 6 will be eigenvalue. We can put here instead of lambda 6, and you will obtain matrix. And then just check if determinant will be equal to 0. If determinant equals 0, so this lambda will be just eigenvalue. You can check that 6 is just determinant of A minus lambda I when lambda equals 6 will be equal to 0. That's why it's just correct. And dimension lambda 1, we have to consider, and dimension of lambda 2 will be equal to 2. Yes. You can solve equation system. Instead of A minus lambda I, put now for example, let's check the dimension of lambda 2 equal 2. How can we check it? For example, we can put instead of lambda 0, A minus lambda I. When instead of lambda we will put 0, it will be just our this matrix itself. Okay, because A matrix, this itself. Then we have to solve this equation system, homogeneous equation system, using our this matrix. And what can we say? We can reduce this matrix to row echelon form. You see, all 3 rows are proportional, the same. That's why all our these elements we can just convert to 0. And now you have only one leading element, 1, and 2 and 3, second and third variables, x, y, z. X, y, z. So now we have just only one leading elements, and we have infinitely many solutions. And instead of y and z, you have to put just different kind of parameters. So it means that number of solutions will be equal to infinity 2, or dimension will be equal to, in our this situation, dimension of solutions. Dimension of solutions will be just 2, because it depends on 2 parameters. Okay, that's why it's correct. If we have just 2 parameters here, it means that dimension of eigenspace of 0 will be equal to. That's why dimension of lambda 1 automatically will be 1, because total number of dimensions of eigenspaces can be equal to, can be not more than 3, because we have 3 by 3 matrix. That's why if dimension of lambda 2 will be 2, that's why dimension of lambda 1 will be just 6. Okay.
Will we have any open questions on the exam?
No. No.
Thanks.
And how many questions we will solve? Will we solve?
I think again will be 10 questions in 1 hour.
Thank you, got it.
Okay, so let's consider just our 10th question. And in our this situation, again, we have just a linear system of equations, and again we have to just consider a set of solutions. And again, no solution, many solutions, dimension of solutions, and so on. So we have to solve this equation system, I think. Let's consider. Okay, so we have just matrix 1 minus A minus A 1. Yeah, so you see, this is just homogeneous system of equations. So homogeneous system of equations always will have solution. It may be a unique solution or infinitely many solutions. And oops. Oh, sorry. Okay. So second one, it will be 1, 0, and 1. Then B minus 1 and 2. And then we have to just reduce some kind of non-convenient situation with touch pen. Okay. First row, we will not change. Second row, we have to subtract from 1, 1, so it will be 0. A, 0 minus A, 1 minus 1, it will be 0. Okay. Then we have to multiply by minus B, first row, and add to third one. So I will obtain 0 here. AB minus 1 and minus B plus 2. Minus B plus 2. Okay. So in our this situation. And let's consider again here. Let's check our these answers one by one. B equals 3 and A equal 2. B equals 3 and A equal 2. B 3 and A 2. It will be 6 minus 1. It will be 5. Here it will be just no, sorry. For any A, B, in any case, this answer, A answer will be not correct because not have solution. This variant is not possible here. So it's not correct here always. Because as I said before, it will be just a homogeneous system of equations, and homogeneous system of equations always has at least one solution. Maybe one or infinitely many solutions. That's why A is not correct. Let's consider B. B equal 1 and A equal 0. A equal 0. So we have here 0. Okay. And B equal 1. So it will be 0, 0, minus 1, and 1. So what about these solutions here? We have second and third row will be not proportional. That's why we will have just second row will be 0, and third row will be just minus 1 and 1. So it means that in our this situation, we will have just two leading elements. Only 2 rows will be linearly independent. Second row will be 0. And that's why number of solutions, if we have two leading elements, mean that dimension of our solution space will depend on number of free variables, 3 unknowns, and 2 number of leading elements. That's why free variables will be 1. Z will be free variables, and system of set of solutions in that case will have just dimension 1. So dimension 1. Infinitely. Oh, yes, B will be correct answer. Because now you see we have just only two rows will be linearly independent. That's why we have two leading elements and three unknowns. Unknowns Z will be just parameter. That's why one parameter solution space depends on one parameter, which means that we will have only a dimension of solutions will be 1. So it's correct answer. You can consider other ones again. Dimension equal 1. You can check if you will put instead of P 3 and A equal 1. So you can consider what will be situation with our matrix. A equal 1 and B 3. A equal 1. So it will be just 0, 1, 0. And here A1, B3. 3 minus 1, it will be 2. And B equal 3. Minus 3 plus 2 minus 1. So in that case, what we will have here, in our C situation, we will have 3 of our these rows will be linearly independent, because second and third row also not proportional. That's why they will be linearly independent. 3 rows are linearly independent, and it means that we have 3 leading elements, and system of equations will be just have unique solution. Unique solution means that it will be only trivial solution, 0, because we have homogeneous system. That's why dimension of our solution space will be equal to 0, 0 space. That's why C is not correct. Again, B1 and A equal 0. We have considered it before in B that dimension should be equal 1, but it is dimension 2. That's why it's not correct as well. And this one. And B3 and 1, again, it's the same like in C, but dimension here equal just 1 or 2, which is not correct, because dimension in our that case, we have considered it will be just 0 space. That's why it's not correct as well. And we have 3 and 2. Infinitely many solutions, and dimension SAB equal 3. Dimension SAB may be 3 only in situation when we will have 3 free variables. But in any case, 3 free variables we will have only if our this main matrix will be 0 matrix, but it's not 0. So at least one of our these rows have linear elements. That's why the dimension of solutions may be just 2 or 1, but not 3. Okay, because we cannot obtain here all 3 variables cannot be just free. At least one leading elements we have, and that's why number of free variables will be not more than 2. Okay, that's why this kind of answer also will be wrong. Okay, I think that's all for today's. If you have questions, please, you can consider.
By the way, have you been recording this lesson?
Yes.
Where can I find it?
Yes, maybe tomorrow I will put this kind of lessons, video of our these lessons on Telegram.
And one more thing, are
Mhm.
our points subtracted if answer is incorrect?
Yes, yes, you will have penalty. I don't remember now what will be exactly the number of penalty, but you will have some kind of penalty. Yes, it will be computed automatically, because you see this kind of quiz, this kind of program. This program will work on your exam as well, and this is maximum number of mark will be 100, and from 100, I think. So you see. No, I not remember exactly what number of penalty, what will be value of penalty, but you will have penalty in any case. Okay.
All right. Thank you so much. Thank you for
I think
listening.
I think you see here from first question is not correct. That's why in our this situation penalty will be minus 15 minus, yes, 15, and from 1000. Each of our this quiz, each of our this question will be marked by 100. Total number which you can obtain will be just 1000, and 15 from our this 1000 will be just marked like penalty if question will be not correct. 15 means that 1.5%, I think. Okay, so this is penalty. Yes. Okay, on 13 January, you will have second lesson, second advising hours you will have, and you can meet there. But by the way, you can put some kind of questions if you will have on Telegram chat before our this 13th. So we can consider as well. Okay. This is some kind of questions about practice taking 12. I don't know. See you. Yes. Okay, on 12, we will have no practice on lag 1 in any case. I don't know about other subjects. Okay, our lesson will be on 13 January. Okay, see you.
Thanks.
Thank you.
Mm-hmm.